The next thing that you need to know in Bohr's atomic models is the Rydberg's equation. So, what is Rydberg's equation? Basically, Rydberg's equation adalah this formula. Okay, so you just kena tahu je this formula, kena hafal this formula. So macam mana you dapat this formula? You dapat this formula melalui this mathematical expression. Basically, bila you cari perbezaan photon energy in two different energy levels, and you just masukkan sahaja delta E equals to H nu, nu equals to C over lambda, and from the simplification of these mathematical expressions, makanya terhasillah Rydberg equation. And you should know N1 adalah elektron at ground state and N2 pula adalah elektron at excited state. Okay, sebab kan ada emission. Emission kan mestilah daripada elektron at excited state jatuh dekat ground state. Therefore, you should know bila you nak guna N1 dengan N2, the value untuk N1, the value of electron at the ground state must be less than the value of electron at excited state. Berbeza ya, tak sama dengan equation earlier that we did together, which is delta E is equals to RH 1 over N initial squared minus dengan 1 over N final squared. Rydberg equation tak sama dengan transition energy equation. If you nak cari transition energy, you kena guna this formula. And the Rydberg constant for the transition, this is transition energy formula. Okay, so for transition energy formula, RH will be 2.18 times 10 to the power of negative 18 joules, because you want to find the transition energy. Okay, in Rydberg's equation, you want to find the lambda. Lambda ni apa? Wavelength. So bila you nak find the wavelength, makanya Rydberg constant yang kamu kena guna berbeza. Okay, you have to use if you nak guna Rydberg equation formula, you kena guna Rydberg constant 1.097 times 10 to the power of 7 per meter. Okay, you kena guna this Rydberg constant. Kalau you nak cari transition energy, you guna transition energy punya formula, you guna Ni, you guna Nf. The Rydberg constant pun will be different, which is 2.18 times 10 to the power of negative 18 joules. If you nak cari wavelength melalui Rydberg's equation, you kena guna N1 dengan N2. N1 adalah electron at ground state, N2 adalah electron at excited state. RH, the Rydberg constant will be different, which is 1.097 times 10 to the power of 7 per meter. Meter kan adalah unit untuk length, kan unit cari wavelength. So kalau 1 over lambda, if let's say you masukkan unit per meter here, so you dapat jawapan dalam per meter. So kalau you nak kira lambda, you just inversekan je calculation dia. Okay, so you terbalikkan calculation, makanya nanti you akan dapatlah lambda is equals to dalam unit meter. Sekarang ni pula kita nak study pasal significance of the atomic spectra. In Lyman series, the frequency of the convergence of spectral lines can be used to find the ionization energy of hydrogen atom. Okay, macam mana you nak find the ionization energy of hydrogen atom? You boleh tahu melalui frequency of the convergence. Apakah itu frequency of the convergence? So, if let's say you ada emission line diagram, kan? The x-axis mestilah bermula dengan the lowest energy level, which is contohnya n equals to 1. And then makin naik ke atas, makin increase dia punya energy level. So bila contohnya n equals to 1 and then n equals to 2, n equals to 3, 4, 5. Okay, lepas tu bila makin bertambah energy level dia, makin meningkat energy level, makin rapat-rapat line dia. So bila line dia rapat-rapat, this is when we call as continuum limit or convergence limit. So that is when the n energy level is at infinity. Okay, so if let's say you ada this line spectrum with few lines here, ada beberapa line kat sini, you tengok ni, makin ke kanan dia punya line makin rapat-rapat sampailah ada one thick line here. So this one thick line here adalah continuum limit. Okay, continuum or convergence limit. Apakah itu? It is when the energy level n is at infinity. Okay, so basically kalau let's say soalan cakap convergence ke ataupun in atomic models of the atomic spectra, if let's say dia mention about convergence or it's they mention about continuum, so you should know that the n will be at infinity. Okay, so apakah ionization energy dan kenapa kita nak cari dia, nanti kita akan discuss kemudian. Okay, so the next thing that you bolehlah nak ambil tahu ialah the first line of the Lyman series. Actually, the frequency of the first line yang dekat Lyman series ni is more than the frequency of the first line in the Balmer series. Okay, sebab you tahu bila you buat emission ni, you akan release photon energy which is delta E equals to h nu, and you know that nu is equals to c over lambda. So the other equation that you can relate is delta E is equals to hc over lambda. Okay, so you will know that makin ke kanan makin bertambah radiant energy, dan juga makin ke kanan makin bertambah frekuensi, and makin ke kanan juga makin berkuranglah wavelength. Okay, so that's why we can conclude here the first line of the Lyman series, the frequency dia is more than the frequency of the first line of the Balmer series. Okay, kenapa Balmer ni berkala? Because Balmer berada di visible region. Visible region kan boleh nampak color-color rainbow. So that's why dia color-color. Okay, tadi kita belajar jenis line spectrum di mana you start daripada kiri. Bila you start daripada kiri, makin lama bila energi dia makin bertambah, maka the continuum or converging limit akan berada di sebelah kanan. So this will be the first line. Okay, and this will be the continuum limit. What happen kalau let's say your line spectrum starts from the opposite side, starts from the right? Okay, makanya this will be the line of the first line. Okay, this will be the first line, and makin lama you tengok jugalah yang ni dia start, since dia start daripada kanan. Macam mana you tahu dia start daripada kanan? Sebab makin ke kiri dia punya line makin dekat-dekat. Bila makin ke kiri line dia makin dekat-dekat, makanya makin ke kiri dia ada pertambahan energy level. Energy level dia makin bertambah. Okay, so that's why makin lama makin rapat. Therefore, dia punya n at infinity berada di sebelah kiri. Okay, converging limit dia berada di sebelah kiri. So basically apa yang Miss nak cakap kat sini, kamu akan dapat dua jenis line spectrum yang berbeza. Tapi cara nak baca dia lebih kurang sama saja. Okay. So if you dapat different kind of line spectrum, you kena tahu, you kena pandai macam mana cara nak baca line spectrum. So cara nak baca line spectrum, you kena tahu macam mana nak determine first line, and then you kena tahu macam mana nak determine converging limit or continuum limit. So you can know these two kalau let's say you boleh baca melalui line dia. Okay, so macam mana you nak baca melalui line? So you tahu kalau let's say makin bertambah energi, line makin rapat. Okay, so if you look at this one, this line spectrum, okay, pertambahan energi tu semakin ke kanan semakin bertambah energi. So that's why semakin ke kanan semakin rapat-rapat line dia. Okay, therefore continuum limit dia di bahagian kanan, first line di bahagian kiri. In this kind of line spectrum, makin ke kiri makin bertambah energy level dia. So that's why we can conclude the first line di bahagian kanan, continuum limit pula di bahagian kiri. Okay, tadi kita bercakap mengenai ionization energy. So what is ionization energy? It's actually the minimum energy yang diperlukan untuk buang 1 mole of electron daripada 1 mole of gaseous atom. So for example, tadi kita nak cari ionization energy untuk hydrogen atom. So if let's say you ada hydrogen atom in gas phase. Okay. So bila you buat ionization energy, maknanya daripada hydrogen atom in gaseous phase, dia akan remove 1 electron from 1 mole of gaseous atom. Maknanya terjadilah H+ ion. Okay. X ni adalah represent element, tapi Miss masukkan teruslah sebab tadi kita nak cari ionization of hydrogen atom kan. So kiranya bila hydrogen atom ni dalam gas phase, dia buang 1 elektron daripada atom ni, dia akan jadi ion kan. So bila dia buang elektron tu, dia memerlukan energi. So energi yang diperlukan untuk buang, untuk remove this 1 electron from 1 atom of hydrogen gas, itulah yang dinamakan energi tersebut. Okay, energi untuk buang this electron daripada 1 mole of hydrogen atom gas, itulah yang kita namakan sebagai ionization energy. Okay, basically energy yang kamu perlukan untuk remove the electron from the atom, that is what we call as ionization energy. Okay, so ionization energy ni semuanya positif sebab energy always required, sebab kita memang always perlukan energy untuk remove electron. Okay, macam mana you nak find ionization energy di dalam eksperimen kalau dibagi this line spectrum? Okay, kalau you dapat this kind of line spectrum, apa yang Miss cakap tadi, kamu kena tahu macam mana you nak tentukan first line, and also you kena tahu macam mana nak tentukan converging limit or continuum limit. So if you look at this line spectrum, you know that makin ke kiri, dia punya line makin rapat-rapat. So therefore, makin ke kiri, dia punya energi makin bertambah. So bila makin ke kiri, energi makin bertambah, you can conclude here that line di kiri ni adalah line convergence limit. It is when n at infinity. Okay, and the first line will start dekat line paling kanan sekali. Okay, so this will be the first line. Okay, untuk cari ionization energy experimentally, okay, you boleh cari melalui wavelength at convergence point. Okay, so kan tadi earlier, actually from the previous slide, kan ada cakap untuk cari ionization energy of a hydrogen atom, you boleh tahu melalui frequency at convergence limit. So actually you boleh tahu melalui sama ada lambda, sama ada melalui wavelength at convergence limit ataupun melalui frequency at convergence limit. Okay, for example, if you ada this kind of line spectrum, you kena tentukan siapakah first line, siapakah line at convergence limit. Okay, soalan tanya, this is the Lyman series of spectrum of hydrogen. Okay, and soalan suruh kamu cari ionization energy of hydrogen from the spectrum. So, if you look at this spectrum, first thing first that you need to know, you kena cari first line and cari convergence limit. Okay, macam mana nak cari dua benda ni? Okay, you telitikan this line spectrum. Okay, makin ke kanan ke makin ke kiri, line dia makin dekat-dekat rapat-rapat. I believe that makin ke kiri, line dia makin rapat-rapat. So therefore, makin ke kiri, energy level dia makin bertambah. So therefore, line dekat bahagian kanan sekali, this will be the first line. Okay, and line yang dekat bahagian kiri sekali will be converging line. Okay, converging line, ataupun di mana bila line di mana n is at infinity. Okay, and apa nombor-nombor ni represent? This number represent the wave number. Okay, so wave number is actually unit dia per meter. Okay, wave number actually is 1 over wavelength. So that's why lah dia per meter. So kiranya and then kan dia bagi info number ni, actually the first line is equals to 8.22 times with 10 to the power of 6 per meter. Okay, wave number sama ada you boleh describe it as 1 over lambda, or also wave number adalah you boleh describe dia as expression nu, lepas tu ada bar di atas itu. Okay, another information ialah converging line. Converging line ni dia ada wave number of 10.97 times 10 to the power of 6 per meter. So, bila nak cari ionization of hydrogen, you boleh cari melalui wavelength of the converging line, or you boleh cari melalui frequency of converging limit. Okay, for the solution here, untuk tahu ionization energy of the hydrogen atom, you boleh gunakan this equation. Delta E kalikan sahaja dengan 6.02 times 10 to the power of 23 per mole. Okay, so delta E you boleh dapat melalui H kalikan dengan C over lambda, and this lambda mestilah wavelength of the converging limit. Okay, or lambda. Okay, tadi kita dapat information wave number. Wave number is actually 1 over lambda. So, kita dapat converging limit, dia punya wave number adalah 10.97 times 10 to the power of 6 per meter. So untuk tahu lambda, you just inversekan sahaja this equation, this expression. So kiranya lambda ke sini and then 10.97 di sini. So if let's say 1 bahagikan dengan 10.97 kali 10 kuasa 6, you akan dapatlah jawapan dia in meter. Okay, so you akan dapatlah what is it, the wavelength of the converging limit. Okay, alright, so you tahu H adalah Planck constant, which is 6.626 times 10 to the power of negative 34 joule second. C adalah 3 times 10 to the power of 8. Lambda adalah, okay, sama ada you ambil this lambda ataupun if you break down this equation, you boleh tahu yang C over lambda kan melalui C kalikan dengan 1 over lambda. So that's why lah dia tak adalah kira lambda ni berapa. Okay, so dia just masukkan sahaja the information yang ada. Okay, so C adalah speed of light, which is 3 times 10 to the power of 8 meter per second. 1 over lambda, masukkan sahaja 10.97 kali 10 kuasa 6 per meter. Okay, sebab C over lambda kan ibaratkan C kalikan dengan 1 over lambda. So that's why you tak perlu tukar pun. So you akan dapatlah the delta E is actually 2.18 times 10 to the power of negative 18 joules. Untuk tahu ionization energy, you kena kalikan dengan Avogadro constant. Okay, so bila you kalikan dengan Avogadro constant, you akan dapat joules per mole. Okay, so sekarang ni dia saja-saja je ni nak tukarkan dalam kilojoules per mole. So kalau nak tukar dalam kilojoules per mole, kenalah bahagikan dengan 1000. So dapatlah 1312 kilojoules per mole. Okay, so this is actually the ionization energy of the hydrogen atom. Kiranya you kira dulu the delta E, you kira dulu the photon energy, and ambillah wavelength daripada converging limit. Okay, so kalau let's say C over lambda is equivalent to C times with 1 over lambda, so that's why lah tadi kita guna saja wave number tu, tak perlu nak inverse ni. Example kedua, dia suruh kamu cari wavelengths of the first line and the onset of the continuum limit for the Lyman series for hydrogen. Okay, Lyman series ni adalah bila if let's say you ada electron at excited state jatuh dekat ground state and 1 equals to 1. Okay, so kalau first line bermaksud mestilah dia punya electron at excited state tu must be equals to 2. Okay, so that's why terhasillah first line of Lyman series is because bila electron at excited state bermula daripada 2 jatuh pada ground state equals to 1. Okay, so untuk tahu wavelengths bila ada transition of energy, transition of electron ni, you boleh gunakan Rydberg equation. Okay, barulah ada function sikit Rydberg equation ni. Okay, basically kalau you nak tahu wavelength for the transition electrons from excited state to ground state, makanya you bolehlah gunakan Rydberg equation. Okay. Di mana RH yang kamu gunakan, Rydberg constant yang kamu gunakan, tak boleh guna Rydberg constant sama macam you nak cari energy. Okay. So you kena tukar Rydberg constant untuk cari Rydberg equation. You kena guna Rydberg constant dia 1.097 kali 10 kuasa 7. Okay. Tapi this unit dia adalah m-1 per meter. Kan sebab 1 over lambda. And you masukkan N1 untuk Lyman series, the ground state is equals to 1. Okay. N2 adalah electron at excited state equals to 2. Kalau let's say first line, mestilah the first excited state electron kan, which is 2. Okay, so sekarang ni bila you calculate, you akan dapat jawapan you in 1 over lambda dahulu. So the answer that you will get ialah dalam unit m-1. So untuk cari lambda adalah wavelength kan. Untuk cari wavelength, you kena inversekan your calculation. Kerana you kena buat 1 bahagikan dengan answer and you will get the answer in meter. Okay. So barulah you akan dapat wavelength equals to 1.21 times 10 to the power of -7 meter. Okay, so macam mana nak tahu? So sekarang ni you dah dapat dah cari wavelength for the first line of Lyman series. The second one, you need to find the wavelength for the onset of the continuum limit. Okay, kalau let's say soalan mention pasal continuum limit je, you should know that it is when at n equals to infinity. So since this is a Lyman series, that means dia punya ground state must be always equals to 1. So therefore continuum limit dia adalah dia punya excited state. That means if dia nak cari onset of the continuum limit punya wavelength, it is between continuum limit. Continuum limit ni ialah bila energy level n equals to infinity. Jatuhlah elektron dia daripada infinity, jatuh dekat ground state n1 equals to 1. Sebab kenapa? Sebab Lyman series. Okay. So untuk cari diorang punya wavelength, untuk cari wavelength yang ada transition of electron, you boleh gunakan, again you can use the Rydberg equation formula. Okay. Where RH, where the Rydberg constant needs to be 1.097 times 10 to the power of 7. Okay. Since your electron at excited state adalah infinity, so you can safe assume that it is equals 1 over infinity equals to 0. Okay. So ni still lagi 1 over lambda, 1 over lambda. Okay. So bila let's say you solvekan this mathematical expression, you akan dapat jawapan you di dalam 1 over lambda. And you akan dapat unit dia in meter -1. So untuk cari lambda, you kena, untuk cari wavelength, you kena make sure you jadikan wavelength ni as the subject. So nanti 1 bahagikan dengan answer in per meter tu, dan you akan dapatlah jawapan wavelength for the onset of the continuum limit of the Lyman series is 9.12 times 10 to the power of -8 meter. Kalau soalan tak mention nak suruh cari in nanometer, you tak perlu tukar in nanometer. So dia akan jadi okey saja macam ni. Okay, to check your understanding, you bolehlah cuba this question. Okay, so apa question yang cakap? Dia nak suruh kamu cari difference in energy. Okay, the keyword here ialah difference in energy between the second and third orbit of the hydrogen atom. Okay, so if let's say you tak dapat tahu benda ni, you lukis. So if let's say you ada first orbit, second orbit, third orbit. So that means the second orbit ialah bila n equals to 2, third orbit ialah bila n equals to 3. Okay. So that means dia bagi tahu apa ni? difference energy between the third and second orbit ni adalah sebanyak 3.03 times 10 to the power of negative 19 joules. Soalan suruh kamu calculate the frequency of the emitted light when electron transitions take place between these two levels. So nak tahu frequency, you boleh guna equation delta E is equals to H nu. H sudah tahulah Planck constant. So nu is equals to delta E overkan dengan Planck constant. Delta E ni you masukkan saja. Planck constant you carilah constant Planck ni berapa. So nu adalah frequency. Frequency unit apa? Unit dia adalah in second or hertz. So you try to find that out. Okay, untuk try this yang kedua pula, soalan suruh kamu calculate the wavelength of the first line in the Balmer series and the last line of the Balmer series. Untuk this one, you bolehlah gunakan Rydberg's equation. Okay, and then you just imagine if you ada Balmer series. Okay, Balmer series ni adalah bila ground state is equals to berapa? Lyman balik, pasar, break, putus. So, if Lyman, the ground state equals to 1, Balmer ground state dia mestilah equals to 2. Kalau first line bermaksud, kalau let's say first line, if let's say the ground state equals to 2, makanya the first line ialah bila excited state dia equals to 3. Okay, so this will be the first line. The last line will be at the convergence limit. Okay, so bila at convergence limit, this will be the last line. So you kena kira dua benda yang berbeza ni. As much we have discussed about Bohr's atomic models, tetapi dia ada beberapa limitation ya di dalam Bohr's atomic model ni. Okay, Bohr's approach dia tak ambil kira for the emission spectra of atom yang ada more than one electron. Okay, kenapa kita asyik kira ambil kira emission spectra of hydrogen atom? Because hydrogen atom dia hanya ada satu saja elektron. So that's why lah Bohr's atomic model ni dia ada limitation dia. Dia boleh explain the hydrogen atom saja. Okay, since that hydrogen atom hanya ada satu elektron saja. Okay, and then Bohr's atomic model juga dia tak explain kenapa ada extra lines appear in the hydrogen emission spectrum when the magnetic field is applied. Also, actually, electrons ni adalah wave-like. Okay, that means dia tak boleh define the precise location of the wave because wave extends in space. So these are the three limitations of Bohr's atomic model. Okay, disebabkan Bohr's atomic models ni tak dapat explain the dual nature of electron, sebabkan electron kan dia ada wave-like punya properties. Kalau let's say dia ada wave-like punya properties, that means electron ni kita boleh tahu kedudukan dan juga speed of the electron. Okay, tapi Bohr's atomic model tak dapat nak tentukan kedudukan dan juga speed of the electron. Makanya, therefore, adalah de Broglie's postulate. Postulate ni apa? Assumption. Makanya, de Broglie, dia buat assumption and come out with this formula, lambda equals to h over m nu, yang membolehkan from this formula kita boleh dapat cari velocity untuk sesuatu elektron. Okay, next, Heisenberg's uncertainty principle pun dapat menerangkan pasal dual nature of electron bila Bohr's atomic models fail to do so. Okay, So, Heisenberg ni dia keluarkan dua formula di mana kita akan dapat position dan juga momentum of electron. Okay. Also dapat tahu speed ataupun velocity of the moving particles of the electron. Okay, basically dual nature of electron ni, since Bohr's atomic models fail to explain the dual nature of electron, makanya that's why lah ada de Broglie's postulate and also Heisenberg's uncertainty principles. Kita tak guna pun sangat diorang punya formula and calculation ni, tapi you kena tahu saja, okay? Heisenberg dengan de Broglie berjaya untuk rungkaikan dual nature of electron. Kalau de Broglie dia dapat tahu from the punya formula, dia dapat tahu velocity of the electron, tapi from the Heisenberg bukan saja dia dapat tahu momentum dan juga position of the electron, tetapi dia juga dapat tahu the velocity of the moving particles. Okay. Basically, daripada Heisenberg uncertainty principle ni, kan since you boleh tahu momentum, therefore kalau semakin besar objek tu, semakin high probability of finding the electron in an atom or molecule that is known as orbital. So that is all about subtopic 2.1. So I hope that you boleh tahu each of the formulas in subtopic 2.1, and I hope that you tahu macam mana nak gunakan setiap satu formula tersebut. Okay?